What if the force you have trusted all your life to keep your feet on the ground is not only more mysterious than you realize, but also the source of countless misconceptions that almost everyone believes, without question? Imagine for a moment that everything you think you know about gravity from school lessons, movies, and even casual conversations is only a simplified version of a far stranger reality than you could ever guess. Most people picture gravity as a simple, invisible, hand-pulling object straight down toward Earth. And that mental image feels intuitive because it choose, daily experience, drop a book, and it falls, let go of your coffee mug, and it crashes onto the table. But that simplicity hides a huge mistake. Because gravity is not merely a pulling force, it is a curvature of space and time itself. When you drop something, you are not just letting it be dragged downward. Instead, the object and Earth are both moving toward each other, and the enormous size of our planet makes its motion imperceptible to us. This subtle misunderstanding has made generations think gravity is simpler than it truly is. Almost like a magical invisible string holding us down. Another mistake almost everyone makes is believing that gravity is strong only near the Earth's surface and vanishes in space. The sight of astronauts floating weightlessly inside the International Space Station reinforces this illusion, and it seems obvious that in space there is no gravity at all. But in reality, gravity at that altitude is nearly 90% as strong as it is on Earth's surface. The astronauts are not free from gravity. They are in a constant state of freefall, orbiting the planet. This perpetual falling creates the illusion of weightlessness. Yet the same gravitational force that holds Earth's oceans and atmosphere together is what keeps them in motion around our planet. Many people also believe that heavier objects fall faster than lighter ones, a notion so common that even children assume it must be true. Drop a stone and a feather in a room full of air, and the rock reaches the ground first, reinforcing the idea. But the truth is that gravity pulls all masses equally. The difference in fall rate comes from air resistance. The feather floats slowly because the air pushes against it much more than it does the denser rock in a vacuum. Where air is absent, both objects would hit the ground at exactly the same time. This simple experiment, repeated hundreds of years ago, changed the course of physics, proving that intuition can mislead us when it comes to fundamental truths about the universe. Say deeper and even more misunderstanding is to think of gravity as a force like pushing or pulling an object with your hands a century ago. Newton described gravity as a mysterious force acting at a distance, but Einstein's revolutionary theory revealed something far stranger. Gravity is the warping of space and time. By mass, a planet like Earth bends the space around it, and objects follow the curves created in this space-time fabric. This is why light itself bends near massive stars, and why time itself slows down under strong gravitational fields. It is not that something invisible pulls objects, but that the very stage of the universe is curved, guiding all matter along its contours. People also assume gravity is a fixed, unchanging constant that applies equally everywhere on Earth. Yet subtle measurements show that gravity is slightly stronger in some places and weaker in others depending on Earth's rotation, its shape, and the density of underground formations. Mountains, valleys, and even hidden underground caves can create tiny variations detectable by sensitive instruments. These small deviations allow scientists to map the structure of the Earth without digging a single hole, revealing a hidden world beneath our feet that we never see but constantly feel. Even more surprising is the fact that gravity extends its influence far beyond what most of us imagine. It governs the dance of planets, stars, galaxies, and even the mysterious motion of dark matter throughout the cosmos. But despite all we know about its effects, gravity remains the least understood of the fundamental forces. We have yet to reconcile it with quantum physics, and attempts to unify gravity with the forces governing atoms and particles continue to challenge the brightest minds on Earth. The same force that causes an apple to fall from a tree is the same force shaping the orbit of planets billions of miles away, and yet its deepest nature eludes us entirely. Many people also think of gravity as permanent and predictable, but it can do strange and counterintuitive things in extreme conditions. Around black holes, gravity becomes so intense that not even light can escape. Time slows dramatically near the event horizon, and space itself is twisted into shapes that are impossible to visualize. The universe hides some of its most extreme and mind-bending phenomena in places dominated by gravity, reminding us how little we truly understand the cosmos. Gravity is so familiar that we rarely stop to think about it. We take it for granted with every step we take, every breath we exhale, yet it remains one of the universe's most profound mysteries. The more we study it, the stranger it becomes, and the more mistakes we realize we have been making for centuries. Maybe that is why it is so easy to misunderstand. Gravity looks simple and ordinary, but it is a force that challenges even the smartest scientists to rethink reality. If a force that has been shaping life, planets, and the entire cosmos for billions of years can still baffle us, What does that tell us about the mysteries we have yet to uncover in our own lives? Think about it. Share your thoughts and stay curious, because the universe rewards those who keep questioning and exploring.